This video, I'm going to go over example 7 on 1.3 functions and relations note. The function f, g, and h are defined as follows. We have 3 functions to look at. For each function, find the domain. Write each answer as an interval or union of intervals. So let me go ahead and find the domain of f of x first. So f of x, we need to look at 2 things here. First, we want to make sure that we find the excluded values. Denominator cannot be equal to 0. And what else? We want to make sure that the radicand is greater than or equal to 0 so that we don't have any negative numbers under square root. All right, let's solve these 2 conditions and find their intersection. The denominator as you can see, is x minus 5. So we'll go ahead and set up that x minus 5 cannot be equal to 0. And we solve this for x. Add 5 to both sides, you get x can't be equal to 5. All right, let's solve the other one, radicand. Where is the radicand? The radicand is, let me pick green color, negative x plus 2. So what I'm going to say is that negative x plus 2 must be greater than or equal to 0. And we're going to solve this inequality. Subtract 2 from both sides. I'll get negative x is greater than or equal to negative 2. Now remember, we have to divide by negative 1 here, which means we need to flip this inequality. X is now not anymore greater than or equal to, but flip it. Less than or equal to negative 2 divided by negative 1. We get positive 2. All right, let me graph these 2 in the same number line so that I can find their intersection, okay? All right, 2 numbers, 5 and 2. 2 is smaller, so let me put that on the left. 5 is bigger, so let me put that on the right. What kind of circles do we need? I'm going to draw an open circle at 5 because they said x can't be equal to 5. So we're going to have an empty circle right here. What about right here? We're going to draw a closed circle at 2 because of this equal to bars, less than or equal to. Closed circle at 2. Notice that it says x is less than or equal to 2, right? Because it said less than or equal to, we're going to draw the arrow to the left, okay? Arrow to the left of what number? 2. Arrow to the left of 2. That's what we're going to do. So starting at 2, we're going to the left. You know, I'm not allowed to go to the right. X has to be smaller than 2. So it's kind of, okay. And then I wanted to go to the right side just because I wanted to like jump over the hole. But I guess we don't have to do that. So let's go ahead and write the domain here. The domain is where this arrow is going. If we keep on going to the left, you are going to negative infinity. So domain is from negative infinity to 2. And because 2 had a closed circle, we're going to make sure to draw a square bracket. And that's it. There's no arrows in between 2 and 5 or from 5 to positive infinity. So the only domain, the only interval that isn't the domain of this f of x is going to be from negative infinity to 2. But make sure to draw that square bracket after 2. So, okay, this is the domain. I should be probably a little more specific. This is domain of f. Now let us find the domain of g, okay? Okay, so let me go ahead and copy down that problem. I hope I have enough room. Sorry. So let's find the domain of g. So g is a, let me write it down. You know what, guys? Let me try to see if I can copy this function. All right, I'm going to go ahead and paste it over here. So that's my g of x, and g of x is just a rational function. So we're going to go ahead and say that the denominator can't be equal to 0. On your exam, I want you to set that up, please, instead of just writing your final answer. So say that x squared minus x minus 42 can't be equal to 0, and we're going to go ahead and factor this. There are many different ways you can solve a quadratic equation, but I'll try to give you the ones that are factorable because I think that's how you're gonna the type of problems that you're gonna see on your Alex homework this week. All right, x and x. And we'll look at different methods later. When we get to chapter 2, we're going to look at completing the square, or we're going to review the quadratic formula. But this one is factorable, isn't it? Because 6 times 7 is 42. And if I make positive 6 and negative 7, if I add these two numbers, I will be able to get the negative 1 in the middle. So this is perfectly factorable. Now let us solve this by the zero product property. X plus 6 can't be equal to 0, or x minus 7 can't be equal to 0. I basically set each of these factors not equal to 0, and if I solve these, subtract 6 from both sides on this one, x can't be equal to negative 6. Let me circle this. And if I add 7 on both sides, I will get that this second factor gives us that x can't be equal to positive 7. All right, let me graph them. Okay, and that's the only condition. There is no square root, so I don't have to say radicand is greater than or equal to 0. There's no square root. So put the small number on the left. Negative 6 is small. 7 is big, so let me put it right there. Both get open circle. Okay, make sure to draw the open circles because we can't have those two values. But, they didn't say anything else about any other values. So what's going to happen is we can have everything to the left. Oh, that's a little too thick. We can have everything to the left of negative 6 and everything to the right of 7. And a lot of people kind of stop right there. They forget that we can have everything in between these numbers too. So don't forget that we have that interval in the middle too. So what you are looking at is 3 separate intervals, okay? Let me try to help you see this. Let me try to use different colors. So you see the yellow section is to the left of negative 6, and I'll keep the middle one a green. In between negative 6 and 7, we have another interval, right? And then to the right side of it, let me just use the red color. You see 3 different intervals. So what we're going to have to do is write down 3 different intervals. So let me do that, okay? So one that's all the way on the left is going all the way to negative infinity to the left. And it stops at negative 6. All right, that's the yellow interval, guys. And then what? Let's go ahead and write the one in the middle. The one in the middle starts from negative 6 and then 7. Whenever you're writing the interval notation, make sure the small quantity, the smaller, is on the left. Negative 6 is smaller than 7, right? Negative infinity is smaller than negative 6. So make sure to put the small and the bigger when you are writing the interval notation. So let me show you what I often see. Some students write it this way. They say, hey, negative 5 to negative infinity. I know what you mean, but this is the wrong way of writing the interval notation. If you want to write an interval that goes left of negative infinity, the right way is to write the negative infinity first and then negative 5. Put the small things on the left first, okay? Now that's one little thing about the interval notation if you never used it before. But let me go back and write down the last interval, the one that I used the red highlighter for. So this one starts at 7, right? And it goes all the way to the right, so we're going to go to positive infinity. So what we just found, this is the domain of G, okay? Okay, I need to do one more and I'm out of room. I plan on putting this PDF on Canvas for you so that you guys can have notes. So I just made it a little bit smaller because in case the margins don't show up. But let me go ahead and copy this h of x down here and find that domain, okay? So let's find the domain of h of x, the very last one. It's just a rational function. So we're going to say that the denominator can't be equal to 0. Which means, what's the denominator? This little guy right there. X squared plus 25 can't be equal to 0. And I'm trying to solve this. And I factored the previous denominator. Remember when I had this, I factored it. So, if you're looking at this, I think it's very common for people to make a mistake here because when you see x squared minus 25, you know that is x plus 5 and x minus 5. When you have difference of two squares, difference of two squares. I think I called it dot one semester. The difference of two perfect squares can be factored this way, but this is not a difference. This is a sum. This is not factorable, okay? But someone may argue something like this, like, hey, I think this can be factored as x plus 5 and x plus 5. Well, let's see if that's true. If you factor this out, what will happen is that you get x squared plus 5x, I'm foiling guys, plus 5x plus 25. What happened is that not only that you're going to have your x squared and the 25, the middle two terms will add up to 10x. So they're not the same. So this guy is not actually factorable in using real numbers. So what we're going to have to do is either, hold on. I can go ahead and solve this by subtracting 25 from both sides. Then I'll get x squared is equal to negative 25, right? Now what, guys? How do you get rid of squaring? Well, to get rid of squaring, you have to take square root of both sides. But I hope you noticed something. We're like, uh-oh. Oh, not uh-oh. I mean like, uh-oh. We can't have negative number as radicand, right? Type that in. What happened if you type in square root of, let me get my baby calculator out. We were doing this yesterday in class. Square root of negative 25 is undefined. It's not a real number. Okay, later we'll say that is 5i, but for right now, that's not a real number. So what's going on over here? Let me come back and talk about this. This is not a real number. What does that mean? The function h of x does not have an excluded value. Okay, what does that mean? Well, no one is excluded. Everyone is okay. So any number will be fine in this function. So there is no excluded value, which means the domain can be anything. The domain is going to be all real numbers. So domain of h is all real numbers, but I don't know if you remember or if you learned how to write all real numbers using interval notation. I mean, imagine if you have a number line and, you know, it really covers everything. Everything to the left, everything to the right, literally everything. So in interval notation, all real numbers goes like this. Negative infinity first, and then you put the positive infinity. So that is the domain of h. Okay, so hopefully, now you see this one was a little different, right? All real numbers for the domain. So if you see an exam problem like this, instead of just throwing me that, oh, the domain is all real without work, I do want you to show me that you attempted to solve for that excluded value and that excluded value did not exist. Therefore, you know, that's a sufficient reason for you to say, stop and say that the domain is going to be all real. But that's it for example number 7. And so instead of making a giant, like long video going over all the examples, I'm going to make shorter videos going over just maybe like 1 or 2 examples at a time. So I'm going to stop this video. So that is it